My name is Ria, and in this video, I'm going to teach you what the three-body problem is. So what is the three-body problem? I'm going to start way back at the basics, well, if physics can be basic. Anyways, gravity is a natural phenomenon in all things with mass that draws them together. It's the force that keeps planets in orbit, our feet on the ground, and even subatomic particles together to form atoms. In 1687, Isaac Newton published the universal law of gravitation in his major work, Philosophiae Naturalis Principia Mathematica. It basically states that any two bodies in the universe attract each other with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. But what happens when there's more than two bodies in question, perhaps three? Well, I'm not the first one to think about that, and that's why the three-body problem exists. The three-body problem involves taking an initial set of data that specifies the positions, masses, and velocities of three bodies for some particular point in time, and then determining the motions of the three bodies in accordance with the laws of classical mechanics, which include the universal law of gravitation and Newton's laws of motion. In the past, the three-body problem usually dealt with a very traditional model of the sun, the moon, and the earth. However, as technology has advanced and has given us opportunities to see more of our universe and solar system, the problem has been relevant in analyzing movement in ternary solar systems, which contain three suns, and even the modeling of how particles affect each other. The most straightforward and so far accurate way that scientists have been able to solve the three-body problem is through the use of three coupled second-order differential equations, wherein xi denotes the vector position and mi denotes the mass. A complete solution of the three-body problem includes the positions of all three bodies for all time, given this initial data set. A problem arises due to the fact that three bodies very rarely repeat their motion. It is generally even accepted that three bodies do not ever repeat their motion at all. Only 16 families of solutions among billions of examples of three bodies in motion have been found up till now. The first family of solutions that I will discuss are the Lagrange-Euler solutions found in the late 18th century. These solutions constitute the central configurations for the three-body problem. The simplest of configurations, these families of solutions involve three evenly spaced bodies moving around in orbit at a constant speed, much like a merry-go-round. It satisfies the problem because after every complete turn of the bodies to the points of the initial velocity and position, the cycle will repeat. Another family of solutions was discovered in the 1970s by Michel Henon and R. Brauch, appropriately called the Henon-Brauch solutions. These involve two bodies dashing back and forth in a thin orbit while the last body orbits outside in a circle. The third family is the Moore figure-8 circle, discovered in 1993. In this scenario, three bodies of equal mass move around in a figure of 8 like that. Most recently, in 2012 to 2013, 13 new families have been discovered by physicists Milovan Suvakov and Veliko Dimitriasinovic at the Institute of Physics in Belgrade. Among these 13 new families are the yarn solution and the spherical figure-8. More solutions than these 16 have been found, but they have been deemed restrictive three-body problems because they require very specific conditions to work, like alterations of the value of the gravitational constant. For this reason, many solutions to the three-body problem are not considered true solutions. In the modern lens, applications of the three-body problem have been extrapolated to quantum mechanics. The hydrogen molecular ion, or H2-, is an example of the quantum three-body model in practical application. This model involves the movement of two protons and an electron. Additionally, gravity assist involves the three-body problem. Although solutions of the three-body problem are few and far between, there is hope that more bright minds will discover more solutions to it and maybe even demonstrates of it in nature. This concludes my lesson on the three-body problem. I hope you enjoyed watching and thank you for listening.